All right, it's 11. Good morning, everyone. Thank you for joining us today for Innovation Resiliency 2020. My name is April Downey. I'm the Federal Field Marketing Manager for Sonatype. Our topic today is Embracing DevSecOps, a changing security landscape for the U.S. government. And I'm here to introduce our speaker, DJ Schleen. DJ is a DevSecOps advocate at Sonatype and an international speaker, blogger, instructor, and author in the DevSecOps community. Before we begin, I just want to let you guys know that I am recording the session. So if you have any questions during the presentation, please feel free to put them in the chat. Everyone is and should be muted for the best recording quality. And I'm super excited to have you guys on here with us. So I'm going to go ahead and pass it over to DJ.
Well, hey, everyone. Thanks for joining again, and appreciate April for the introduction. So I'm going to be doing a quick talk. It's only about 30 minutes. I got a lot of slides to go. I'm in beautiful Colorado where the snow has fallen, and we're all cooped up indoors like we would normally be if it was snowing. So this is called Embracing DevSecOps. It's a changing landscape in the federal government. And I'll just advance to the next slide. So DevSecOps, everyone's sort of heard this word. Everyone is starting to use it, actually. It's been around for, well, millennia, but in the past 5 years, DevSecOps has really become a term. And it's not just for hipsters. Like, it's not just a concept that's going to come and go. It's building security into our software. It's the cultural communication factors, and it's the principles of lean manufacturing that's helping us build safer software sooner. A lot of it is to reduce the risk, right? You're either compliance-based organization or risk-based organization. And I came from a large healthcare organization where we were risk-based, even though we were under different compliance and different regulations. And one of the things that we believed was if we addressed all the risk and compliance was a part of that risk and the governance was part of that risk, we'd have a more secure software security program and security profile across the organization as a whole, either physical or digital. So culture is a big part of it. The idea of having developers and operations and security all being part of a same group is something that, we've been talking about for years. Having tribes work together, feature teams, this kind of thing, all working together in harmony, really. I was part of a smaller group where we had someone from development, someone from operations, someone from product, somebody doing the front end, someone doing the back end. Everybody was part of this one feature team, and we were responsible for the development of a feature as it came out of the product owner's head all the way to production, and we maintained it in production. But because we worked together on these features, we all had an understanding of why it was important, what we needed to do, and how we needed to operate that in production. So it was a group collaborative effort. And it's the three ways, right? It's flow, feedback, and experimentation. So these are the concepts that you've heard Edwards Deming talk about. So, another part of this DevSecOps concept is that we want to automate and disseminate and investigate a lot of things. So automation of products and the tool sets that we put in our development pipelines. These could be messaging systems. These could be information gathering systems. Anything that you can automate, you should automate. And when you automate tools and practices, you're taking the guesswork out of things. You're making things repeatable processes. And that has a lot to do with audit compliance, is just having that repeatable process for development of software. Disseminating information is important. So that's the feedback aspect of DevOps, where you're collecting information from multiple points in your DevOps pipelines, and you're making actionable KPIs out of them. So a KPI being something that you're measuring, something that you can action, and something that's relevant to the people who are getting them. You can have a metric, and a metric is just a KPI without action or without a threshold, right? So delivering those to the appropriate stakeholders is something that we want to do. An investigation. So if you're getting security information from these tool sets that are coming out, or even just any operational tool that you're using, like a build server, a Kubernetes platform, or that kind of thing, or any kind of orchestration platform that's delivering your software, You want to be able to investigate any abnormalities. So when you want to know the normal of your systems, and then see what is happening to that normal to make it abnormal, and investigating why that happens. And that can be the introduction of vulnerability, a breach detection, or anything to that matter. So why are we even talking about DevOps? Why are we talking about changing our processes, or what kind of risks are associated with DevOps or with traditional security and operation teams? And this is the big one. Developers outnumber security 100 to 1. And if you put in operations, it's 100 to 10 to 1. And we found that to be consistent across a lot of different organizations and a lot of different industries. And the government's no different, where it's almost like a skeleton crew of technical security resources. Security is a big group of folks, right? They're the threat hunters, there's the third-party risk professionals, there's people looking at compliance and identity and access management, and then there's the part that actually deal with architectures and application security. This is what we're talking about in the 100 to 1. These are the people who can actually explain the coding behind a SQL injection and how to remediate those kind of things. The other part of why we're doing DevSecOps is that Agile really isn't agile enough, right? So if we look at this diagram here, we can see that Agile, you have this iterative phases of creating product and creating releases. So the Agile mindset would say that we have 6 iterations, we have a 12-week release, and after every 2 weeks, we're going to look at what's been done, we're going to package it up, and then we're going to hold it all until we release it in 12 weeks. Well, that's just not fast enough when it comes to addressing breaches. And that's where DevSecOps and DevOps come into play, where you're actually iterating on a feature. You're not iterating or you're pushing that feature to production right away. Ideally, the most advanced DevOps organizations will push a feature once it's complete or even partially completed into production and put it behind a feature flag. And that's so that they can get used to reacting quicker and just getting these product features out. So as soon as you start doing that, then Agile just becomes like a stake in the sand. Because if you're delivering every day, multiple times a day, then how do you deal with release planning? And that's where things like ITIL and Agile and even waterfall, you can do all these things with DevOps, but when you're releasing multiple times a day, it's really hard to figure out how to report that up. So that's one of the things that Agile is just not agile enough. So let's take a look at the timeline of an attack. And this is Equifax. And this is another reason why we want to start automating and going to DevOps practices. So on March 7th, Apache Struts releases an updated version to thwart a CVE, so a vulnerability that was in the Struts ecosystem. And then on March 10th, Equifax, they were breached through the Struts vulnerability. But July 29th of that year, the breach was discovered by Equifax. So, we see March to August, or, that's a long time for an adversary to be in your environment. So we start looking at the probing phase of this hack, and that was going from March to May. And then that exploit was really happening from May to August. So Equifax didn't even know about this. And, then it's crisis management and the fire start, and they start looking at remediation, and that's in August. But the damage had already been done by that point. And the really sad thing about this is, we saw, and Sonatype, we have the Maven Central Repository. So we start seeing a lot of these downloads that are coming down, and we can track how over time, what percentage of population actually pulls down these components and these frameworks. So when we saw that Struts vulnerability was announced back in March 2017, for months after that, it was still downloaded the same amount of times. So even 12 months after the Equifax breach, people didn't catch on to this, right? And that's where either people just didn't know about the breach, people didn't have open source supply chain detection tools that could actually say, hey, these components are bad. And the problem was, these are versions that were vulnerable. This wasn't the version that was fixed. So people were still downloading the versions that were vulnerable. And they weren't alone. So, that March 17, 2017, we had NSA that reveals the Pentagon servers were scanned by the nation states. Struts exploit was published to ExploitDB at the time. March 9th, Cisco observed a high number of exploitation events. March 10th, we had Equifax, the Canadian Revenue Agency, Canada Statistics, or StatsCan. It just kept going, right? So 3 days in March, and then the rest of the story, we had Okinawa Power, India Post. So even today, right, we still have vulnerable versions coming out, and 57% of those Fortune 100 companies are still using these vulnerable components. And this is another reason why we want to be able to react quicker is the average days before the vulnerability is exploited. It's gone from like 2006, it was 45 days. And then 2017, it was 3 days. And if we look at the way this graph is trending, now it's less than 24 hours. It could be even hours. This is because open source software is open. Everybody has access to it. As soon as it hits GitHub or any repository, we're consuming it as consumers, but hackers are also consumers, and they're using the same code, and they can see the same places where this code can be exploited, and then they can commit that back into those repositories. So again, this is about risk, and the big part of open source software risk and the supply chain risk, especially for any industry, especially for the government, is 85% to 97% of code that you're developing or applications that you're developing are things that your developers don't even build. Like bringing in parts of an automobile that are manufactured by somebody else, and all your developers are doing is maybe painting it and putting it together. This is a lot. Imagine 3% of web applications is that 97% chunk. That's stuff that your developers are assembling. Those are the tools that the code that you'd use static analysis for, but you wouldn't be scanning other people's code because it's open source and there's other tools that can do that for you. And this is looking at in this special publication 800-161. So it's looking at the supply chain risk, and that's what we're talking about here with open source components. The biggest threat to any organization is the use of open source software and how it gets into our ecosystem. If you haven't taken a look at this, 800-161, take a look at it. It talks about threats versus vulnerabilities and the adversary, vulnerabilities being external or internal, and then adversarial and non-adversarial. A threat is somebody developing a component by themselves that you use everywhere and introducing vulnerabilities that aren't pulled in from the outside. And then the likelihood of those threats being exploited, adversarial versus non-adversarial, it all comes down to risk, right, and degree of harm. This is published right in that report. And this is another diagram I pulled out of that report, which is talking about the visibility. So as you start looking further and further down your supply chain, it gets a lot more foggy because a lot of these components that you're pulling into your systems, they have dependencies, and those dependencies have dependencies, and those dependencies have dependencies. I did a little video called 0 + 2 is 154. And if you check it out on YouTube, you can probably find it or just Google it. It's on Sonatype's website as well. And the interesting thing that I found was when I was doing a little Go application written in Go, and I brought in 2 dependencies, it brought in 154 sub-dependencies, of which 3 had vulnerabilities. So the top level showed no vulnerabilities because the scanning tool I was using to test was only doing name-based matching. But when I was digging into it with more advanced tool sets, I found that there's vulnerabilities way down the supply chain. And that's what I really needed to take a look at. So say hello to your software supply chain. So suppliers, those are the open source projects that you're using. The warehouses are your component repositories. So those are like NPM or NuGet or Maven or those kind of things. The manufacturers, those are the software development teams. And those could just be an individual too. These are folks that are building software, putting it out on the App Store. These could be big manufacturers or builders of software, such as your own internal teams. And then the finished goods being your software applications that you're pushing out to your consumers, either internally or externally. And not all parts are created equal. We start looking at different components, and as soon as you start automating them with DevSecOps practices and DevOps practices and integrating CI/CD, we start looking at the automated requests for Java components. In 2018, this is 2-year-old data, and it was at 146 billion downloads. Start automating these even more, and with every single build we're doing, we're pulling new dependencies in. And this is just going to be exponential, and I'm excited to see some of the latest data that we're collecting on these. And we're looking at almost 1,000 new projects a day, 10,000 new versions of these components a day and up to 14 different releases per year. And as we start automating the software using DevSecOps or CI/CD, with every feature coming out, that's a new release. We could be introducing vulnerabilities into code or have vulnerabilities added into code faster than we can determine what they are. So this is a huge and massive risk for any organization. In the last 7 days, right? So we had 5 billion packages in the last 7 days. 4 years ago, it was 50 million. 10,000% growth in downloads just over like 5 years. That's crazy. That's absolutely nuts. 37% of jQuery inclusions were known vulnerable. 40% of Angular inclusions are vulnerable. These are just the way it is. So if you scan any open source repository as it comes out, things are getting better. There's more hygiene involved in these, but it's a technical debt that's being remediated by the community at this point. It's nothing that you have control over internally unless you fix it yourself, and then you have a choice of either pushing it back to the repositories or keeping that branch internally. Coming back to that 87 or 85 to 97% of your ops are assembled components. And it's the same for containerization. 80 to 90% of those containers are assembled from other layers, right? So your base layers, base images, base operating systems, that's 80% to 90% of your app. If you're building a web service, for example, you're going to use a base operating system, put your binaries on top of it, and that's it. But that's 80% to 90% that you didn't even write. Pulls from Docker Hub have also increased. 2017, we're looking at 12 billion. And what these slides are trying to show is that we're relying more and more on the open source community for software and pulling that in. And then time. The time to repair these components is long. If we start looking at multiple components with vulnerabilities and then people fixing the vulnerabilities, we're looking at sometimes 233 days, the mean time to repair. Like that's a year to repair that many vulnerabilities across those components that have known vulnerabilities. And that's a long time. It's a lot of horsepower from people. And when open source projects are really voluntary, when is that going to be fixed? So that introduces a lot of risk into the time and project planning of any application that you're developing. And here's the Struts 2 mean time to repair. So it was identified on March 7th. Apache fixed it on March 7th, and it was 0. This is a very rare occasion where you don't have any time to repair because it was fixed right away. The problem with this is that there's still versions that are vulnerable that people are downloading. And so if you analyze 170,000 different Java components and the unique components part of that, 11.1% of them have known vulnerabilities. And this is based out of the 7,500 organizations analyzed. This is all in our State of the Software Supply Chain reports that have come out of Sonatype. You can get them at Sonatype's website as well. We have a new one from last year. Some of this data as well is built off our DevSecOps community survey. And we have a new version of that coming out in April. And there's some pretty interesting information in there about how folks are adopting DevSecOps practices. And threats are real. I use this picture because everyone thinks that hackers wear hoodies. Not really. Sometimes they're just people sitting in their basement in their pajamas and they're hacking just for fun. They really don't wear hoods, and neither does a child in the basement either. But you start looking at breaches that have happened over the past few years. Heartbleed, we had 14% of people. This is the DevSecOps community survey. Saying that they had verified a breach, and that's just consistently increased over the years. So now we have 31%, and it's actually increased even more than that in 2020. And these are people who have suspected or verified a breach because of open source software in the last 12 months. And that is a compelling reason to start looking at that supply chain. And then malicious coding and a whole shifting battlefront of attack. We're going to share this deck later, but NPM type squatting, there's Docker Hub images, PyPy typo squats. A lot of these different repositories are getting components or security vulnerabilities associated with them. Backdoored NPMs and PyPy. It's interesting when you start looking at these code repositories. Sometimes you'll find a repository that's a couple years old and it hadn't had any commits happen to it in the last year or so. And now it's starting to get a lot of different commits and pull requests and things getting added to the code. And it's sort of like this dormant application that a lot of people are using all of a sudden gets this rapid amount of commits. You have to think that's sort of suspicious. Or you're looking at these commits coming in, people will do a pull request, but they won't understand the code that they're merging into their code base because it might be complicated. It could be shifted around into multiple functions and classes and methods. And when that gets merged in, it basically puts a vulnerability in there that people can breach, like a backdoor, some way to get into a system. So those are the other kind of things that we want to detect when we're pulling into our ecosystem. One of the things I wanted to share as well is I was on a team that we brought in a vendor piece of software, and their software wasn't vulnerable, but it was the first time we ever really had an ability to scan some vendor software. It was in a Docker container or Docker image when it came in, started looking at the layers, found 9 critical vulnerabilities in the components that were being used. So it wasn't the vendor, it was the dependencies the vendor had in their software. And when we looked at it, we're like, oh my God, we're bringing an open source Trojan horse into our organization with this back door that has a call home in it. It was just, it was mind blowing that even the vendors that we had, even though we did a third-party risk assessment on the company itself, the software that they were producing didn't have the tool sets available, or they didn't have the tool sets available to detect these vulnerable components. And a lot of them were just an update to the most recent component. Here we have some scans per week. So, 4 million scans. This is the NPM audit scans. The total scans were like 51% vulnerabilities, 37% were high, and then 11% are critical. And critical vulnerabilities, most SLAs in any large organization is going to say, you have to fix those immediately. It's drop everything and fix it now. The Bouncy Castle vulnerability. This is a library. It's very popular. 2017 had a 10.0 exploitability score. Like, this was the easiest thing that you could possibly breach. That same component later on, almost 9 years later, it's still 11 million downloads per year of this vulnerable component. So even though we see newer components, it doesn't mean those vulnerabilities have been remediated. So, we don't want to boil the ocean here. What we want to do is just reduce our downstream defects. When we start looking at our warehouses, so these are the repositories and the manufacturers and the components coming in, we want to reduce those vulnerable components as we bring things closer to the software that we're developing. So, the idea of trapping these components or blocking them at the door. So as they start getting pulled in, having them come through a proxy where you can say, hey, this is a known exploitability score of 8. We're not letting it in. Starting to reduce that over time as part of your hygiene projects, where you're trying to make sure that the components you're bringing in and you're putting out eventually have the low CBSS scores you can get. So those vulnerability scores and those exploitable scores, you can wrap a program around those. And that's what we did. Is we started off and said, okay, everybody, we have 10. 10 is the maximum you can have. In 3 months, we're dropping that to 7. Get it together and start upgrading your components. And they did. 3 months later, we said, okay, in 3 months from now, we're dropping it to 5. You got to get everything under 5. That started having a little bit of pressure on those development teams because they're saying, well, we've chose these components and these components were good and now they're not. And what do we do? Do we use a different component? Do we fix it? And so there's a couple different things we could do. We could commit back to the repositories and fix it for the community, or we could choose a different, better component or even an updated version of the component. And a lot of times just these version updates manage to fix things. And that's one of the controversial things I believe in, is never pinning a version, because you're only as good as your last scan anyway. And if there's no binary incompatibility and your application still works, you can always roll back that version if it's vulnerable or if it has a vulnerability detected tomorrow, or you can keep it going. And this is where DevSecOps comes into play, where you can quickly react, quickly update, quickly roll back. And that's really important. If you have these old stale components from 5 years ago, guaranteed there's going to be vulnerabilities in there. So protect that software supply chain. the rewards are going to be impressive. You're going to have 90% improvement time in deployment. You're going to save hours every day, and you're going to have that quality in your application. And that's quality is a measure of security and functionality and reuse of code, code visibility, complexity of code. But overall, your application quality is going to increase. Failure is inevitable, and so is hacking. So take a look at that. And if you need to get any further resources, links to the state of the software supply chain, thing you can email right now, DJ plus MITRE at sonatype.com. I have an autoresponder on there, so you'll be able to get any of the slides as well, my reference architectures, links to the state of the software supply chain, and the old DevSecOps community survey. And keep an eye out for the new one coming out shortly. And thank you very much. April, back to you.
Thanks so much, DJ. This was awesome. Again, if you guys have any additional questions, feel free to reach out to DJ, or you can also reach out to myself. My email is adowney@sonatype.com. And please feel free to visit our website, www.sonatype.com.